This one line of code stole $60 million in 2016. It broke Ethereum so badly, the entire blockchain had to split in two. And today, I'm going to use that same exact bug to drain a vault and steal the flag in a hacking challenge. And I'm going to explain every single piece of it like you've never seen code before. So if you don't know what a blockchain even is, perfect. You're exactly who this video is for. Okay, ground floor. 3 words you need, and I'll make them stupid simple. A blockchain is just a shared notebook. Everyone has the same copy, nobody can secretly erase a page, and once something's written, it's written. Ethereum is one of these notebooks. A smart contract is a little program that lives inside that notebook. Think of it as a vending machine made of code. You put money in, it follows its rules automatically, no human needed. Nobody can stop it. Nobody can change it after it's deployed. Whatever the code says is law.
And ETH is the money, the coins that live in that world, real value. So when I say this vending machine is holding 10 ETH, that's thousands of dollars sitting in a program.
Here's the catch that makes hacking these so spicy. Because the code is law and can't be patched, if there's a bug, it's free money. There's no support line to call. That's why people pay millions for these audits, and that's why CTF challenges, capture the flag, let us practice finding these bugs safely. Solve the puzzle, get a secret flag, prove you did it. So our target is called, and I did not name this, PP farming. PP here stands for performance points. It's a vault, an ATM, that's holding 10 ETH, and our entire goal is one thing. Empty it completely. The challenge is solved the moment this vault's balance hits exactly 0. The description literally says, surely nothing could go wrong. That's the universe daring us. Let's read the code and find what went wrong. The whole contract is tiny, like 20 lines. There's a scoreboard that remembers how much each person has put in. This mapping is just a spreadsheet. Your wallet address on the left, your balance on the right. You send in ETH, it adds that amount to your score. Deposit. Simple.
And this, withdraw, is where it all falls apart. Watch the order of operations, because order is everything here. Step 1, it checks your score. Step 2, it sends you your money. Step 3, it sets your score back to 0. Read that again. It pays you first and erases your balance last. Hold that dot. It's the entire hack.
Forget code for a second. Imagine a bank teller following these exact rules in this exact order. 1. Check how much is in your account. You've got $100. 2. Hand you the $100 in cash. 3. Then write 0 in your account book.
Sounds fine, right? Now here's the evil part. What if, in between step 2 and step 3, right after she hands me the cash, but before she updates the book, I tap the counter and say, hey, I'd like to withdraw again.
She looks at the book. It still says $100 because she never got to step 3, so she hands me another 100. And before she can update it, I ask again, and again, and again. Each time, the book still says I'm owed money because she's stuck handing out cash and never reaches the part where she writes it down. I walk out with the entire vault, and on paper, I only ever withdrew once. That, right there, is reentrancy, re-entering the withdrawal function before it finishes cleaning up. The contract trusts that the outside world will wait politely while it finishes, and it won't. In our contract, this gap between paying me and zeroing my score is the open door. And the magic detail? In Ethereum, when a contract sends ETH to another contract, the receiving contract gets to run code the instant the money lands. That's my chance to tap the counter and say, again.
So I can't do this from a normal wallet. A wallet just sits there. It can't run code when it gets paid. I need to deploy my own little contract, whose only job is to be greedy. We're going to read the whole thing, top to bottom, and I promise every line will make sense. This file is called exploit.sol. Top 2 lines are just paperwork. The first declares a software license. Solidity nags you if you skip it. The second says, this code is written for Solidity version 0.8-ish. Boilerplate. Every contract has it. Move on. This is the first thing that might look scary, but it's simple. An interface is a remote control. My contract needs to press buttons on the target ATM, but it needs to know what buttons exist, so I list them. Donate, withdraw, is solved. I'm not rewriting the ATM. I'm just describing its buttons so my code knows what it can call. Think of it like the buttons drawn on a remote without the TV's guts inside. Now my actual contract. 3 things it remembers. ATM is which vault I'm attacking, the address of the target. Immutable just means set once, never changes. I lock onto one target and that's final. Seed is the chunk size I'll withdraw each loop. We'll set that to 1 ETH. An owner is me, so I can take the money out at the end. That's the contract's whole memory. A constructor runs once, the moment the contract is born, and never again. It's the setup step. When I deploy this, I hand it the ATM's address. That's the _ATM part, and it saves it. And message.sender means whoever is calling right now, which is me, so it remembers I'm the owner. Born, configured, done. Here's the trigger. Payable means this function can receive ETH when I call it. I'm going to send 1 ETH in with it. Message.value is how much I sent, and I save it as my seed. Then line 1, I donate PP to address this meaning my own contract. So the ATM now thinks I'm owed 1 ETH. Line 2, I call withdraw PP to start the chain reaction. And the last require is just me double checking at the end. Is the vault actually empty now? If not, blow up loudly. And this is the heart of the whole hack. Receive is a special function with no name. It runs automatically the instant my contract is handed any ETH. So picture it. The ATM sends me 1 ETH, which instantly triggers this, which instantly calls withdraw again, all before the ATM ever reached the line that zeroes my score. That's me tapping the counter and saying again. The 1 ETH check just means only keep looping while the vault still has at least 1 ETH left to give. The moment it can't cover another full chunk, I stop, and the whole stack of withdrawals unwinds peacefully. Last function. After the heist, all that ETH is sitting inside my exploit contract, not in my wallet. Sweep just forwards everything. Address this.balance, my contract's whole balance, back to owner, which is me. Empty the getaway car into my pocket. Done. So zoom out. An interface to know the buttons, a constructor to aim at the target, attack to kick it off, receive to loop the withdrawals, and sweep to collect. That's the entire weapon.
Why exactly 1 ETH? Because 1 divides evenly into 10, so it lands on perfectly 0, not 0.5 left over. Picking the wrong number leaves dust behind, and the challenge won't count as solved. Small detail, big difference.
Okay, we built the weapon, but something has to actually deploy it and pull the trigger on the real challenge server. That's this second file, solve.s.sol. It's not a contract that lives on the blockchain. It's a script, a to-do list that runs once on my machine and fires off the transactions for me. Let's read it. It's short. Top, I import 2 things, Foundry's scripting toolkit and my exploit file from a second ago. Then run is the function that does everything, and it takes 1 input, ATM, the address of the target I want to hit. I'll pass that in from the command line. vm.startBroadcast is the magic words that mean everything between here and stop turn into real transactions and send them to the blockchain using my wallet. Then 3 steps in plain English. New exploit ATM builds and deploys my attacker, aimed at the target. e.attack, value 1 ether, calls attack and sends 1 ETH along with it. That's the seed money. e.sweep pulls the stolen ETH back to me. Then 1 final require to confirm the vault is empty, and stop broadcast closes it out. Deploy, attack, sweep, verify. 4 moves. That's genuinely it.
2 files. One is the trap, one is the button that springs it.
All right, theory's done. Let's actually do it. First, the challenge server gives me a private instance, my own personal copy of the blockchain to attack. I connect, hit launch, and it hands me 3 things: a wallet with some ETH to play with, a private key, that's my password, and the address of the target ATM.
Sanity check before I swing. Let's confirm the vault really has 10 ETH and isn't already solved. 10 ETH, not solved. Beautiful. Now I deploy my attacker and pull the trigger with one command. And there it goes. Deploy the attacker, call attack, and watch. Boom, boom, boom. 11 withdrawals firing off in a single transaction, the loop eating the vault alive. Let's check the balance now. Last step, collect the prize. I go back to the challenge server, ask for the flag, and because the vault is empty, it checks the rule, sees it solved, and gives it up. And that's the flag. From what's a blockchain to draining a vault with the most legendary bug in crypto in one sitting.
So how do real developers stop this? One sentence. Update your books before you hand out cash. In the biz, it's called checks, effects, interactions. Check the rules, change your own state, and only then talk to the outside world. Watch how one swapped line kills the whole attack. Now, when my greedy contract tries to re-enter, its score is already 0. The require fails, and it gets nothing. Door slammed. 2 lines, swapped. That's the entire fix. And if this feels like a toy, it isn't. In 2016, a project called the DAO held 14% of all Ethereum in existence. An attacker found this exact bug, pay first, update last, and drained around $60 million. The Ethereum community was so shaken, they did something almost unthinkable. They rewound the blockchain to undo it. People who refused to rewind kept the original chain, and that's literally why Ethereum Classic exists today. One missing line, a whole blockchain split in 2. That's the power of understanding what you just learned. You now genuinely understand the hack that reshaped crypto. If your brain just went, oh, I actually get it, that's the goal. Subscribe, because next video can be even nastier. Drop a comment with which bug you want me to break down next. Stay curious, keep your contracts, checks, effects, interactions, and I'll see you in the next one.